Modern manufacturers and brand owners rely heavily on external partners to handle physical production. It creates necessary scale and efficiency. But the moment an OEM issues a forecast, a purchase order, or an engineering change, the operation goes dark. Critical purchase order acknowledgments do not update an operating record. They sit trapped in unstructured email threads. Back in the OEM's Enterprise Resource Planning System, or ERP, the inventory shows original material levels long after the contract manufacturer has actually consumed or scrapped those components. When a customer misses a delivery date, it is rarely caused by a sudden machine failure on the floor. It is a lagging indicator of information breakdowns that occurred across company boundaries weeks earlier. The standard corporate reflex to this problem is attempting to buy a single software license or a centralized dashboard to force transparency. That fails because external partners operate their own distinct technology stacks. They have no incentive to abandon workflows for a customer's new software. When data between a manufacturer's ERP and a partner's quality system fails to align, you're looking at an operating control failure, not a simple reporting error. A single software tool cannot mandate trust between two independent companies. It cannot define shared rules, nor can it mathematically reconcile different data definitions. Solving the black box requires engineering a shared operating architecture across the boundary, rather than forcing an identical application onto both parties. Operating architecture means determining exactly what information must cross the manufacturing boundary, who owns that data, and how trustworthy it must be before you take action. This approach is called vendor independence. Instead of attempting a massive system replacement, you engineer around the ERP, manufacturing execution, and warehouse systems already operating in the environment. You map the boundaries of those existing systems to define records, identifiers, and data ownership before a new software product is selected. This phase locks in partner identities and establishes strict role-based permissions, creating an auditable trail of access across the entire network. True architecture respects the legacy environments of both companies while safely standardizing how operational data moves between them. Attempting to synchronize every single field across every system creates overwhelming noise and instantly increases operating risk. This diagram shows the required alternative. Information must be filtered down to shared signals, the specific data points required for the OEM and partner to make joint decisions. We isolate critical metrics: exact work in progress, material consumption, engineering revisions, quality holds, and available production capacity. We then set the integration cadence for those signals. How quickly a decision must be made dictates whether the data moves in near real time, triggers on a specific event, or updates on a scheduled batch. Curating these signals, rather than dumping entire databases, protects the data sovereignty of both businesses while delivering exactly what is needed to manage production risk. Cloud and data services are applied directly to the integration point. They reconcile definitions, ensuring both sides agree on the exact mathematical calculation for metrics like scrapped inventory. Governance establishes the operational rules of the road. It assigns clear ownership, exact escalation paths, and approval thresholds for the inevitable exceptions that occur. Only when those records and governance rules are fully stabilized do we introduce artificial intelligence into the environment. We utilize AI to classify those exceptions, extract data from complex documents, and predict delivery risks based on the validated signal flow. Cloud, data, and AI are not isolated IT projects. They are specific engineering capabilities applied strictly to solve the overarching visibility problem. The operational blind spot is replaced by a secure, auditable workflow, connecting the OEM directly to the contract manufacturer. Material shortages, capacity constraints, and quality holds are caught in the planning phase, weeks before escalating into a delayed shipment for the end customer. A properly engineered boundary transforms outsourced production from a high-risk black box into a tightly controlled, predictable asset. When deploying this architecture, resist the instinct to roll it out across your entire manufacturing network at once. First, map the exact information flow between the OEM and the contract manufacturer to define the shared model. Next, execute a controlled pilot. Prove the records, test permissions, and validate the exception model with a single external manufacturing relationship. Expanding the architecture across your broader network must be driven entirely by the operational evidence generated during this specific pilot phase. Define the business goal and locate the exact operational constraint. We will engineer the systems required to solve it.